Good afternoon, students. Today, I'm so happy to welcome you for Zoom class. Now, I'm going to introduce a new topic, that is Euploidy. And today, we are going to discuss what is Euploidy and types of Euploidy, right? Actually, Euploidy is a condition in which an organism possesses more than one basic set of chromosomes. My dear students, an organism, rightly I can say, an organism possesses more than one basic set of chromosome. That is called Euploidy. I repeat once again. An organism consists of more than one basic set of chromosomes. Actually, basic sets is nothing but the constant number of chromosomes of an organism, right? So every organism may possess constant number. The chromosome number is a constant. It is also known as a specific number. Every organism possesses, say for example, right, a human being, we have 46 chromosomes which are happened in condition. So 23 pairs. These 23 pairs are constant or specific, or a constant number, or it is also known as a specific number. So among these constant number or specific number of chromosomes, one or more than one basic sets of chromosome is increased or added with the normal number of chromosomes. That is called Euploidy. So before that, you should understand what is Ploidy. Ploidy is nothing but there is an alteration in the number of chromosomes of an organism, right? That is called Ploidy. Here, Euploidy means adding of chromosome. It may be one set, or two set, or more than two set, or three set, four set. So these adding of chromosome with the constant number or a specific number of chromosome in an organism, that is called Euploidy. Generally, Euploidy that it causes variation in the number of chromosome. I mean, in the constant number of chromosome or a specific number of chromosome or a fixed number of chromosome in an organism, that is called Euploidy, right? Actually, a specific number, it is also known as a fixed number. This fixed number, it is going to be retained even generation after generation. So, for example, 23 pairs, constant number of chromosome, or 23 pairs, they are the number of chromosome or specific number of chromosome or a fixed number of chromosome in human being. This number, it is going to be retained. It is going to be retained even generation after generation, right? So that is called a specific number. And this specific number, there is an alteration by adding one set, or two set, or three set, or four set, or five set, or six, or seven. So it depends upon adding of chromosome with the constant number, a specific number of chromosome in an organism, that is called a Euploidy. Simply I can say an organism that possesses more than one basic set. Here, basic sets of chromosome, nothing. They are the constant number or a basic set or a specific number or a fixed number of chromosomes. In that number, there is an alteration by adding of chromosome, either one set, or two set, or three set, or four set, or five, six, so etc. So this is called the Euploidy. My dear student, is very easy to understand, right? Euploidy. Okay. The next, I'd like to talk about Euploidy, right? As I said to Euploidy, I'd like to mention the chromosome number of wheat. Actually, wheat consists of, it's a chromosome number, if it is hexaploidy, right? Hexaploidy, and its chromosome number is 72. Actually, this is 72 is a chromosome, it's a hexaploidy. In that, I'd like to make a difference between hexaploidy, right? First of all, let me take haploid condition, right? Haploid and diploid. So diploid means the total number of chromosomes in an organism that is denoted by diploid, that is designated by the symbol 2n stage. Whereas haploid means the half of number of total chromosome in an organism that is designated by this symbol, right? So when I can designate, I can indicate this symbol. N stands for haploid condition. So the condition is a haploid, but half of total number of chromosome. I repeat once again, haploid is a condition in which the total number of chromosome is divided into two equal, right? So that is called a haploid. Simply half of number of chromosome in specific manner or fixed number or constant number of chromosome in an organism. So that is called a haploid, right? So here, what is the nature of wheat? Here, wheat is hexaploidy. So that consists of 72 chromosomes, right? So when we talk about the haploid condition, what is its number? So 72, that becomes simply, I can say 36. So now 36 during gamete formation, this hexaploidy converts into triploidy. I mean 3x stage. So what is the chromosome number here? So this is a 3x stage. Then what is the nature of monoploidy? Here I'd like to mention monoploidy. Monoploidy is indicated by adding of a single chromosome or only one basic set of chromosome. So this is called the monoploidy. So X mono. The X stands for monoploidy. Monoploidy is nothing but there is only one basic set of chromosome in an organism, that is called a monoploidy, right? So monoploidy can be designated by X, and diploidy, right? It is indicated by 2x. And triploidy, right? So this polyploidy can be indicated by various. So what is the number of chromosomes in monoploidy? So if it is a triploidy, so the triploid is a 36 number, then what is the number of hexaploid or monoploidy? So therefore 12. So the chromosome number is 12. So the monoploidy chromosome number is 12. So if it is a triploidy means a 3x. 3 basic sets of chromosomes. Here, the basic sets of chromosomes is a 12 chromosome. If it becomes a triploidy condition, so the chromosome number becomes a 12, becomes 36. So if it is a 36 or 3x becomes a hexaploidy, the chromosome number simply 36 becomes as a 72. So this is it is a condition of euploidy, adding of chromosome. Why? Okay. And there is a difference between haploid and monoploidy. My dear students, I'd like to make a difference, right? The first one, haploidy and monoploidy. The first thing is haploidy. Haploidy, and one more thing, that is the monoploidy. Actually, haploidy is nothing but it is a condition in which the chromosome number is half of chromosome number in an organism from the constant number or fixed number. So that is called a haploid condition, right? So for example, we are having 46 chromosomes which are haploid. Then what is its number? 23. So these are 23 pairs. Always the haploid sets of chromosome. 23 pairs are diploid in nature. 23 pairs are diploid in nature. So these are 23 pair, which becomes like a 46 chromosome, which are a haploid in condition, right? So the haploid can be designated by N, simply N, right? Whereas the monoploidy, that refers to X. I mean, the total number of chromosomes in which only one base is set, that is designated by X. X is a monoploidy. And 2x, that is a diploidy. And 3x, that is a triploidy. And 4x, that is a tetraploidy. And 5x, that is a pentaploidy, right? Because the chromosome number, I mean, the basic sets of chromosome is added with the normal structure of chromosome or a constant number of chromosome or a specific number of chromosome or a fixed number of chromosome. Every organism possesses fixed number of chromosome, right? My dear student, don't get confused, right? But haploidy can be as a monoploidy, but monoploidy cannot be as a haploid because the number of chromosome, adding of chromosome is varied, right? I repeat once again, haploid is that is a word that refers to the presence of half number of chromosome in an organism from the constant number or a fixed number of chromosome, right? That is called haploidy. Whereas monoploidy designated by one basic set. Whereas diploidy means adding up two basic sets. And 3x stands for adding of 3 basic sets of chromosome. And 4x stands for tetraploidy. So 4x stands for tetra. If 5x, 5 basic sets of chromosome is added from the normal number of chromosome or a fixed number of chromosome or a constant number of chromosome, that is denoted by 5x. Instead 5x, 6 basic sets of chromosome are added from the constant number or a specific number, that is called the hexaploidy, right? Hexaploidy. So this is a difference between haploidy and monoploidy, right? Haploidy refers to half number of chromosome from fixed number or constant number, a specific number of chromosome in an organism. Whereas the monoploidy means only a single chromosome. I mean, only one basic sets of chromosome is added. That is called monoploidy, right? So this is the difference between haploidy and the monoploidy. My dear students, by adding of 1x, 2x, 3x, 4x, that is called simply, I can say, polyploidy. My dear student, it is very interesting topic, that is polyploidy, right? Polyploidy. Here, polyploidy, poly means many. Poly means many. Ploidy means alteration. Here, ploidy means alteration. From the constant number or a specific number. From the constant or a specific. The constant number of chromosome, right? CH or chromosome. From the constant number or specific number of chromosome, there is an alteration by adding of more than 2 basic sets of chromosome. That is called polyploidy. My dear students, please imagine an organism possesses particular number of chromosome, right? In which more than 3 basic sets of chromosome. That is called from the constant number. Apart from the constant number of chromosome or a specific number of chromosome, more than 3 basic sets of chromosome is added. It is called the polyploidy. That's why I have given 2 words. One is many and another is alteration. Poly stands for many, ploidy stands for alteration in the number of chromosomes in an organism. Simply I can say an organism possesses more than 2 basic sets of chromosome by addition, right? That is called the polyploidy. Now, as I said, polyploidy can be designated by different format, right? SSH, that is a X is a monoploidy. If two basic sets are added, that is a 2x. A 2x stands for diploidy. And 3x, I mean, three basic sets of chromosomes from the constant number, right? That is a triploidy. And if 4x, x stands for number of chromosomes that is added. So 4x stands for tetraploidy. Now, polyploidy can be expressed either 2x or 3x or 4x if five basic sets of chromosomes is added. That is a pentaploidy. Pentaploidy. The polyploidy is available in different format, either triploidy or tetraploidy or pentaploidy. One more I'd like to mention, that is a 6 basic sets. An organism possesses more than 6 basic sets of chromosomes from its own genome. That is called a hexa. 6x means hexaploidy. So this is a types of ploidy in which polyploidy is expressed, right? My dear student, it is very easy to understand. Please follow me. Okay, now I am going to classify polyploidy into following types. My dear students, polyploidy, it is classified into following types. The first one is a SSH monoploidy. Second category is a diploidy. So like that we can classify. The next type is triploidy, right? SSH, tetra, and penta, like that you can classify, right? So generally, polyploidy can be divided into following types by adding of chromosomes, right? They are autopolyploid and the allopolyploid. My dear students, polyploidy is of several types. So here polyploidy can be divided into following types. The first type is autopolyploidy. Autopolyploidy. Second one, allopolyploidy. Allopolyploidy. What is the difference between autopolyploidy and allopolyploidy? Autopolyploidy is a condition in which an organism possesses more than 3 basic sets of chromosomes. So all these chromosomes are derived from its own species. That is called auto. Auto means within the organism, the chromosome which is derived from within the species by adding of more than 2 basic sets of chromosomes. That is called the autopolyploidy. Whereas allopolyploidy is a condition in which an organism possesses more than 3 basic sets of chromosomes which are derived from 2 different species. When they are crossing with each other, say for example A and B, or parental crops are taken, A and B are taken. So among A and B, when A is crossed with B during this time, a ploidy F1 is produced. This F1 organism which possess more than 3 basic sets of chromosomes, which are derived from 2 different organisms. Please understand that more than 2 basic sets of chromosomes which are obtained from 2 different species when they are involved in crossing over. So that is called allopolyploidy. Actually, there is an alteration when 2 different organisms are involved in crossing over, right? So during that time, this very number of chromosomes is derived or obtained from various organs. That is allopolyploidy. Okay. And further, autopolyploidy is further classified into following types. It is very easy to understand. We are discussing the types of polyploidy. Yes, my dear students. Hoping that you can understand, you can follow me. This autopolyploidy is further classified into following types. The first type is autotriploidy. And the second type is autotetraploidy. My dear students, please understand, autopolyploidy is further classified into 2 types. They are autotriploidy. And second type is autotetraploidy. Autotriploid, right? I like to mention big size, right? Because it is not seen clearly, my dear students. The first category of autopolyploid, that is an autotriploid. Autotriploid means an organism possesses more than 3 basic sets of chromosomes. My dear students, it possesses more than 3 basic sets of chromosome. Which are obtained from same species, that is called the autotriploidy. And whereas autotetraploidy means an organism obtains 4 basic sets of chromosome. My dear students, an organism has 4 basic sets of chromosome, right? More than 4 basic sets of, more than 3 basic sets. That is the 4 basic sets of chromosome obtained within the species. That is called the autotetraploidy. I'd like to give some example for autotriploidy, right? My dear student, please understand. I'm going to deal autotriploidy, then you will come back autotetraploid, right? So here autotriploidy, I like to mention the naturally some plants are having autotriploidy, that is a Cynodon, dactyl. It is a dupe grass. Cynodon dactyl is a dupe grass. That is a right example for natural autotriploidy. Which of the following plant is natural autotriploidy? If it is asked, right? Cynodon dactylum. That is nothing but it's a dupe grass. It is one of the grass variety, right? In that, autotriploidy naturally reported, right? Some artificial autotriploidy. Actually, autotriploidy can be induced by artificial method, right? So I'd like to give some example. Sugar beet. Sugar beet and watermelon. Watermelon. Tomato, etc. So these are all the example of autotriploidy, right? So among them, Cynodon dactyl is a natural autotriploidy. Please remember, students, it is very important here. Now talking about Tetraploidy. Actually, autotetraploid means an organism possesses more than 4 basic, 3 basic sets. Simply, an organism has 4 basic sets of chromosomes, right? That is autotetraploidy. Here, autotetraploidy is reported in following cases. The first one is a granite, right? Like to give an example, the first category is grape. Grapes and groundnut. And alpha. Alpha and coffee. Right? So these are the example of, and potato. One more thing I'd like to mention, that is potato. So these are the example of autotetraploidy. I repeat this again. Which of the following plant is an example of autotetraploidy? So they are grapes, groundnut, alfalfa, coffee, potato. One more I'd like to mention, that is the rye plant. So these are the example of autotetraploid, right? Right, students. I'm going to talk about next allopolyploidy, right? Now, allopolyploidy, as I said, an organism possesses more than 3 basic sets of chromosomes which are obtained from 2 different organisms. That is called allopolyploidy. Now, this allopolyploidy can be explained by a different crossing or by different interspecific process, right? I like to take allopolyploidy. Please understand, my dear student, it is very interesting one. Allopolyploidy. It was first reported by Carpech and Co. Allopolyploidy, right? An organism possesses more than 3 basic sets of chromosomes which are derived from 2 different species. When they involve in crossing over, that is a statement to underline. Please follow me, my dear students. So it was first reported by Carpech and Co. Carpech, who is a Russian scientist, in the year of 1927, right? In the year of 1927, Carpech and Co., who is a Russian scientist, who demonstrated allopolyploidy in following plants, right? So, in order to explain allopolyploidy, he has taken 2 different plants. The one is he has taken 2 different varieties. Carpech and Co, my dear students. The first variety is Raphanus sativus. Raphanus sativa is taken, my dear student. It is a radish. Its binomial is Raphanus sativa. My dear student, this is a Raphanus sativa, which is crossed with Brassica oleracea. That is a binomial of cabbage. Actually, he has taken 2 different plants, and what he was thinking, to produce both radish and cabbage on same plant, right? These are 2 different varieties were taken and which are crossed by Carpech and Co. Then what is its chromosome number? Actually, Raphanus sativa, I'd like to mention the binomial of radish, that is Raphanus sativus. Raphanus sativus. Raphanus sativa. That is a binomial of radish, which is crossed with cabbage. What is its binomial? Brassica oleracea. Brassica oleracea. So that is a binomial of cabbage. Right? And its chromosome number, the chromosome number of Raphanus sativa is 18. 18 is a 2x stage. I mean, diploid in condition, whereas the Brassica oleracea also possesses 18. The chromosome number is 18. So during gamete formation, nine gametes from Raphanus sativa and 9 gametes from Brassica oleracea. So as a result, the F1 was here. This is the F1. The F1 was a sterile condition. So he was a greatly disappointed to obtain such a hybrid variety. These hybrid variety that never produces radish from root and cabbage from leaf. Actually, it was planned to produce radish from root and cabbage from leaf. So that aim was simply collapsed by hybridization technique, right? So it was a greatly disappointed, and one more example was taken. That is this F1, it's a chromosome number. What is a chromosome number? So during gamete formation, the chromosome number, if it is a diploid condition, the chromosome number which becomes like, if it is 18, the chromosome number is 9, right? So here 9 chromosome from Raphanus sativa and 9 chromosome from Brassica oleracea. So 9 plus 9, that forms like 18. Now this 18 chromosome is chromosome number is doubled, right? The chromosome number, I mean, the F1 is doubled. The chromosome number is doubling, and as a result, the F2 will be fertility. Actually, the fertility was restored in F2 generation, not in F1 generation, right? Fertility was restored not in F1 generation, in F2 generation, second filial generation. F2 stands for second filial generation. In that condition, fertility was produced. So that means an organism produces both radish and cabbage. Radish produced from root and cabbage is obtained from leaf. So in F2 generation, only these two different vegetables are produced, right? So this is an example of allopolyploidy, right? And one more example I am going to show you that you can understand. Hexaploidy. That is an hexaploidy. My dear students, it is very easy. Hexaploidy means an organism possesses more than 5 basic sets of chromosomes, right? Like in 6 chromosomes, right? That is a hexa. So for that, I'd like to mention 2 different. One is a triticum durum, and the other is a sequence serial. So the first category is taken, triticum durum is taken, which is crossed with the sequence serial. Right, student? It is a wheat variety. This is a triticum durum is taken, which is crossed with the. It is crossed with the sequence serial. So this wheat variety, simply it was crossed with a rye variety, sickle cereal. Then F1 was produced as a fertility. So this is a sickle cereal. When we consider there was a parent, then what is its chromosome number? Durum consists of 28 chromosomes. 28 chromosomes which are 2x stage and diploid in condition, right? So it is its chromosome number is a diploid in nature, right? 28. And sickle cereal, its a chromosome number is a 14. So as a result, we can get it during information 14 plus 14, which are obtained from durum, and the sickle cereal, it consists of simply 7 plus 7. They are gamete formation, right? And what is its nature? What is the condition? Durum is a tetraploidy. Tetraploidy indicated by 4x. And the diploid condition of sickle cereal, that is 2x. So as a result, we can get the gametes are 14. X, 14, 2x, which are a haploid in condition like that. 14 haploid set of chromosome, and the condition is a diploid, right? So here also haploid sets of chromosome, which is a X, and the 7th chromosome also X during gamete formation. So the F1 will be 14 plus 7, so 21. This 21 chromosome is altered or doubling by a chemical agent that is called C. Actually, I am going to explain how this hexaploidy is obtained in plant, right? When we cross a tetraploidy of durum is crossed with the sickle cereal, I mean tetraploidy of durum crosses with the diploid condition of sickle cereal, F1 will be fertility. That means that it produces 21 sets of chromosome, but it is what is its condition? They are triploid in nature. This triploid condition of F1 is doubled by using of a chemical agent that is called C. Actually, colchicine is applied here. This colchicine, what is colchicine, my dear student? It is an alkaloid which is capable of doubling of the constant number of chromosomes or fixed number of chromosomes. I repeat once again, colchicine is a chemical agent that induces polyploidy. I mean, colchicine which induces alteration. Particularly, I can say a doubling of chromosome. So the 21 becomes right 42. So 3x becomes simply 6x. My dear student, it is easy to understand. Please follow me. So 3x which becomes 6x. So answer, this hexaploidy was produced and triticale. So triticum, it's a genus name. This hexaploidy condition of F1 was reported as a new plant, that is a triticale. A triticum is a genus name. Triticum. Triticum and cicale. So as a result, triticale was obtained, right? So the F1 was produced as a triticale, that is the first mad cereal. So triticale is the first. Triticale, how these names are derived? Because triticum durum, its genus name is taken, and Ezekiel serial, its genus name. So both genus name of triticum durum and Ezekiel serial, which combine to form triticale. The triticale is the first man-made cereal. It is the first man-made cereal. First man-made cereal. My dear student, you can expect which of the following is the first man-made cereal. If it is us, you can write triticale. Triticale is the first man-made cereal because this triticale is obtained from triticum durum with the Ezekiel serial. When we cross with each other, F1 was produced a triticale. That chromosome number is 42. Is a 42 chromosome is 6x or hexaploidy condition. Hexaploidy. There will be 6 basic sets of chromosomes, right? So that is the first man-made serial, right? So this is simply something about hexaploidy, my dear students. And one more point is that is actoploidy. So as I said, polyploidy can be classified into so many types, right? There are tetraploidy, triploidy, pentaploidy, hexaploidy, octoploidy, so many ploidies are there, but we have syllabus 2. One is a tetraploidy and the other one is a hexaploidy. Sure, you can expect very 5-mark question, very important 5-mark question. We illustrate hexaploidy with a suitable example. My dear student, please understand. In the hexaploidy, you can expect a question. What is the question? Illustrate hexaploidy with a suitable example. If it is asked, you have tried triticum durum and Ezekiel serial. A class is made between them. F1 was produced in hexaploidy. That means triticale. A triticale possesses 42 chromosomes. These 42 chromosomes are derived by using of colchicine. Actually, the F1 generation in which chromosome number is 21. This 21 chromosome is doubled by the treatment of colchicine. It is a chemical agent. It is obtained from colchicum plant, right? So it is an alkaloid. Colchicine is I'm talking about this is a colchicine. It is an alkaloid. It is an alkaloid. What is the role of this alkaloid? Which induces doubling of chromosome. So this 21 chromosome becomes 42 by using colchicine, right? So hence hexaploidy was obtained in triticale. Now the triticale is the first man-made cereal. Okay, my dear students, so next we pass on to what is the significance of this ploidy. So far we have discussed ploidy. Previously we discussed ploidy, types of ploidy, and euploidy, it is of several types, right? And finally we ended with the hexaploidy. Then what is its significance? Which are very important area. So significance of ploidy. So first of all, many types of ploidy, all the types of ploidy, they are more vigorous and more adaptable. More vigorous and more adaptable. Either monoploidy or diploidy, tetraploidy, penta or hexa, whatever it may be. Many types of ploidy, all the types of ploidy, generally they are more vigorous and adaptable to the environmental conditions, right? Second point, mostly autopolyploidy are used for producing mostly ornamental plants in large quantity. The plants are grown for decorative purpose in the garden of Ooty, Kodaikanal, Erkot, even Erkot, right? If you see, some plants are grown in the garden for decorative purpose. Flower yielding plants, if I can say, flower yielding plant for decoration or decorative purpose. That is called ornament plants. That point. All the types of ploidy, particularly I can say autopolyploidy, they are essential for increasing their fresh weight. Their fresh weight. in order to higher content of water. Due to high content of water, it increases fresh weight, the fruits of polyploidy, right? And one more thing, it is also used to determine the phenotypic effect. My dear students, the phenotypic effect of whether loss or gaining of chromosome, right? So simply, autopolyploidy is used to determine phenotypic ratio in plant also, right? A last point, it also plays an important role in the process of evolution. Whether aneuploidy or euploidy, as we have discussed already, ploidy, it is of two types. They are aneuploidy and euploidy. Generally, it is of two types. They are aneuploidy and eu. Whether anu or eu, all the types of ploidy may play an important role in the process of evolution. So these are all the significance of ploidy. My dear student, here also you can expect 5 more questions. Write about the significance of ploidy. The first point, many types of ploidy that we have discussed, all the types are they are more vigorous and more adaptable to the environmental condition. Second point, all the types of ploidy, generally I can say autopolyploidy and allopolyploidy, they are used for making ornamental plants in large quantity, and they also induces flowering season, right? And mostly the ploidy are used to increase the fresh weight due to a higher content of water in fruits. And whether aneuploidy or euploidy, it also used to determine the phenotypic ratio, phenotypic effect in plants, and whether anu or any type of ploidy, which plays an important role in the process of evolution, right? So thank you for joining, my dear students. If there is any question, please ask. Tomorrow we will continue chromosomal aberration, my dear students. Tomorrow we will continue chromosomal aberration, right? It's this is your time, my dear students, to interact. Please, you can ask any question, right? Dear students, did you understand today what I taught you? Students, am I audible?
Yes, sir.
Yes, sir.
Did you understand what I taught today?
Yes, sir.
Okay, tell me in few words, what do you understand about euploidy? One of you please answer.
It is a condition where
Good. Simply you can say an organism possesses more than one basic set or two basic sets, three basic sets of chromosomes, right? Okay, good, very good. Then could you mention the number of chromosomes in each that we discussed? I have shown a chart to you that you will understand.
72.
72. The what type of ploidy is there in each?
Exoploidy.
Hexaploidy. How do you indicate hexaploidy? By a symbol?
6x.
6x.
6x. Mono, di, tri, tetra, penta, hexa, right? Okay, or could you make a difference between a haploidy and diploidy? My dear students, could you make a difference between haploidy and diploidy? I have given two types of ploidy. Students, are we audible? Did you understand what I asked you? Here, my dear students, I have given the types of ploidy. 3x indicates. What do you mean by 3x?
Triploidy.
Diploid. Then 4x means
Tetraploid.
tetraploidy. Very good. One more question. I'm going to give you. How do you classify polyploidy? How many types are there?
2 types.
What are they?
types.
Autopolyploidy.
Autopolyploidy.
Allopolyploidy.
Allopolyploidy.
Auto. Will you mention the types of autopolyploidy?
Autotriploids.
Autodiploids,
Tetraploids.
autotetraploids.
Very good. Will you give an example for autotriploidy, which is a naturally grown?
Cyanodon dactyly.
Cyanodon.
Dactyly.
Actually, what is it? Cyanodon dactyly. I have given a word.
Doobgrass.
Doobgrass. Very good.
Doobgrass.
And will you list out one more example for autotriploidy?
Watermelon.
Seedless watermelon,
Sugar
apple, sugar beet,
banana.
tomato, banana.
Very good. Then next I have shown two different vegetables, right? Will you mention the binomial, the first vegetable which is widely used for making a delicious food, right? Could you mention the binomial of radish?
Raphanus.
Raphanus
Raphanus
sativus.
sativus, right? Very good. Could you mention the number of chromosomes in Raphanus sativa?
18.
18. Very good. And one more vegetable is taken, which is also used as a vegetable.
Cabbage.
Cabbage. What is its
Cabbage.
binomial?
Brassica oleracea.
Brassica oleracea. Okay.
Brassica oleracea.
Oleracea. Very good. When we cross the radish with the Brassica oleracea, what is going to be obtained in F1 generation? What is its name? What is its name?
It is sterile.
Let us take the genus name of Raphanus brassica and the genus name of brassica. What is it? What is it called? Simply Raphanus
brassica.
brassica, right? So that is F1 generation. Okay, what is its nature? Is it a fertility or a sterility condition?
Sterile.
In F1 generation, it is a fertility. When the chromosome is doubled, it is going to become a fertility in number, right? Very good, mom. And one more example that we have discussed, ploidy. Will you name there, please? Will you mention the name?
Triticum durum. Fecal cerule.
Triticum durum, crossed with the name of the plant.
Fecal cerule.
Okay, cereal. Okay. So when we cross with each other, what's going to be obtained in F1 generation? What is going to be obtained, ma'am? The genus name of Triticum durum is taken. And one more, the genus name of cereal is taken. And what is to be called? Triticale. Which of the following is known as the first man-made cereal? Dear students, let us take, as we have taken genus name of Raphanus brassica and brassica, right? So here also we can take triticum of genus name, and the cereal is one more genus name which will combine to form as a triticale is the first man-made cereal, right? Which of the following is the first man-made cereal? Tell me.
Triticale.
Triticale. Very good, ma'am. And could you mention the number of chromosomes in Triticum durum? My dear students, I have given
28.
different chromosomes. Could you mention the number of chromosomes in Triticum durum?
28.
28. Very good. What is this condition? Whether is it haploidy or diploidy or a diploidy or a tetraploidy?
Hexaploidy.
Right? Very good. Well, thank you for joining. And now I'm going to give you assignment work, right? Please take down. All of you, please take down. And try to read all the questions what I'm going to give you, right? First question. What is Euploidy? Second question. What is ortho polyploidy? Third question. Explain hexaploidy. Fourth one. Write about the significance of ploidy. So these are all very important questions. Please take down and read well, right? Thank you for joining.